We're now going to take a look and a listen at some periodic waveforms. We call these periodic waveforms because they repeat. Notice, this is a sine curve. It repeats over and over. This is called a square wave down here, and it looks square. Notice it's square, has right angles almost. This is called a sawtooth wave down here. It looks like the teeth of a saw. Now, each of these waves, you'll notice, has some similarities. They seem to be about the same height. And if you notice, they repeat after the same amount of distance along the x-axis here. Now, let's take a listen to them. This is our sine wave. Now we'll take a listen to our square wave. Notice that it sounds different from the sine wave. See if you can figure out how you would describe that difference. Sine wave. And this is our square wave. We'll now listen to the sawtooth wave. And notice that it has a different kind of timbre than either of the first two waves that we listened to. Listen to this one again. Sawtooth. Here's our square wave. And our sine. The sine wave is really nature's favorite waveform. Sine waves show up in the phases of the moon, show up in the passing of the seasons. Square waves, down here, these are human beings' favorite wave. The reason is, square waves sort of have this on, off feature to them. And this is something that's really useful for human beings, especially when we do stuff like make computers. Computers really love square waves. On, off, because all a computer really does is look at ons and offs. Ones and zeros, ones and zeros, ones and zeros. And then by putting together a whole lot of ones and zeros, well, that's how a computer works and does everything that a computer does. The square wave also has this interesting type of sound. Can you hear that buzziness to it? That's sort of a sound that sounds like a reed to many people. And in fact, with electronic music, a square wave is usually the starting point for making an instrument that sounds like a reed instrument. Saxophone, clarinets. The sawtooth wave down here, this is, it sort of has a different type of buzziness. And in fact, the sawtooth wave is what a string sounds like. Usually you have to do some more processing on it to make it sound like a string that we're used to, but things like bowed violins will have a sawtoothy kind of a wave to them. Here we go back to our sine. It has a pure tone, frequently associated with things like flutes. Now, this would be a very low frequency flute. This is about 250 cycles per second. In other words, this sine wave is going up and down 250 times every second, and that's why we get this particular frequency and this particular tone. You'll notice that the square wave repeats exactly the same, and the sawtooth exactly the same frequency. So all of these have exactly the same base frequency. But they do sound very different, and they look very different, and the look and the sound sort of go together if you think about it. The sine wave is very smooth. Very smooth. That sort of gives it a softer tone. The square wave, on the other hand, it's rough. It's not smooth at all. And it has this buzziness to it. Similarly, we see with our sawtooth, it also has a buzziness to it. It's a little bit different from the buzziness that we get with the square wave. The square wave some people describe as having a hollow type of sound. And then the sawtooth wave doesn't quite have that same hollowness to it. Just a lot of buzz. So the next thing we're going to do is we're going to take a look at generating these types of waveforms with our calculator. Yes, with our calculator. And that's our next task here.